Hello and welcome to our second video on this integration at A-level for the maths, and we're talking about improper integrals again. And within that improper integral chapter, we're talking about integration using given inverse trigonometric functions. Okay, these are the formulas given in the formula book. Differentiation of these three inverse trigonometric functions are given to as this. And integration of two of them is given to as this. Okay, a couple of things I would like you to note in here. When there's a square root at the bottom, you don't have that coefficient 1 over a. There's no square root at the bottom, the coefficient is 1 over a. That's simple as that, because no square root means that there's a there anyway. Guys, the second thing which is missing in here is, and that why is there no formula for arc cos x over a. Let me just go over that quickly then. Okay, so what it is, people, if you do a squared minus x squared at the bottom and integrate it with a negative sign outside, you get arc cos x over a. Okay, and this goes from that differentiations, check carefully in the formula book. If you differentiate arcs, if you differentiate this, you should get that. So if you differentiate this, you should get that. Okay, so there's only a difference of sign there. So what does that mean, guys? If there's integration of inverse trigonometric functions, we get an answer is arc sine x or negative arc cos x. Both the answers are equal and they're being the same. Okay, so we're looking at exercise 3D. We're looking at some questions from this exercise 3D. All right, so the first question we're looking at from exercise 3D is question number 12. Okay, so have a look, guys. Just copy that question and let's start working that together. Right, the first part of the function question says that this is a function f(x). I'm going to integrate this, giving you an answer in the form of this, okay? And this could be proper normal integration of normal maths as well, but let's see how does that go, guys. So we're going to integrate this function first, so then we look at part B and C a little later. Let's see, integrating these functions, okay? All right, so this is the first thing I get. I split this into two parts. Okay. And then we integrate both these separately. Now there is a trick, guys. Both these integrals will be done using different methods. If you look at this one, I can use this, use substitution or inspection. And this one, I can use this straight as one of the formulas given to us in the previous page or in the formula book. Have a look if you can make sense of it. Otherwise, I will try and do this with you, okay? Right, that's my next stage. Why did I do this? If you want to use that shortcut and inspection, I know the differentiation of this bottom function will be 2x, so I introduce a 2 there and divide by half, multiply by half outside. This is 1 over 4 squared plus x squared to be able to use the formula a squared plus x squared there. Well, guys, so that becomes ln half outside x squared plus 16. I'm telling you what differentiation inspection I used. This is the one, is ln fx, okay? And this one would be the formula, so that is 1 over a, which is 5 times 1 over 4 arc tan x over a, which is x over 4. Right, guys, and then plus c, of course. Now we're going to see if we want to match up with the answer which they've given me in the book. Right, so this is exactly in the form they wanted me. I've just looked in the book. So this is 5 over 4 as your b, and a is equal to half. And then we try and look at the second part of the question, which goes like this. All right, it says, hence show that the mean value of this function over the interval 0 to 4 is this. And guys, mean value, like we've discussed before, it is the integral divided by the full width or the range of the interval. So let's do that mean value now. So this will be, we're going to work out mean value between 0 and 4. So that should be 1 over 4 take away 0. Then the integral of that function fx between 0 and 4. Okay, so let's put that value of 0 and 4 into the answer which we got in part A. Right, so this is what I get when I substitute the values of 4 and 0 into it. So that gives me ln 32 is 2 raised to the power 5. So it will be 5 over 2. So 1/4 outside, 5 over 2 ln 2. Tan arc tan 1 is pi over 4. So this is plus 5 over 4 times pi over 4, right? And take away from it, this will be 2 raised to the power 4. So 4 times half is 2. That gives me 2 ln 2. And arc tan 0 is 0. Thank you very much. So that is 0 there. Okay, so where do we go from here, people? Let's see if we're getting this right. This is 5 over 2 ln 2 plus 5 pi over 16 minus 2 ln 2. And 5 is 2.5. This gives me half ln 2, so 1/4. Half ln 2 plus 5 pi over 16. Okay, and that should be the answer. We can simplify it further, opening up the bracket. And this is it, guys. That's your part B. Okay, we evaluate the mean value function. So part C, we need to do what we need to work out. Hence, write down the mean value of this function, which is -4 times fx. And guys, mean value is the average if your graph is drawn to the highest, guys. -4 fx if that's the graph of the function. So it'll be -4. So it'll be stretched 4 times, it reflected. So if there's if mean value is here, guys, for the original function, it's going to be 4 times and going to negative. So guys, all we need to do is just multiply this mean value by -4, stretch 4 times and going to the negative direction. So -4 times 1 over 4 ln half ln 2 plus 5 pi over 16, and that will work out to be whatever it is, guys. This will be -4, so -1 is -half, and that will be the mean value function of this. Okay, so we're moving on now. We're looking at this next question on this exercise, and the next question we picked up is question number 14 for this exercise. Guys, have a look at that question, then we will work through this together. Copy that question, give it a try, and I'll start working on this. All right, so let's start this horrible looking question, guys. Okay, we need to prove that this is equal to this. Substitution is given to me. Let me start my basic process, guys. Dx over d theta is equal to half cos theta. So my dx will be half cos theta d theta. Is that right? So I'll be replacing dx in here. I'll be replacing x by half sine theta. Let's see what do we get, people, when you do this. Okay, so when x is half sine theta, so 1 minus 4 times 1/4 cos sine square theta, that gives you 1 minus sine square theta, and the square root of that gives you cos theta, because the denominator becomes cos theta. Okay, and the numerator will be 1/4 sine square theta. This integral actually turns out to be, I'll put the limits later, this will be 1/4 sine square theta over cos theta, then dx is half cos theta d theta. That's my substitution. Cos theta cancels. So I get 1/4 here, half here. I actually get 1/8 sine square theta d theta. All right, guys, so now the sine square theta integration, we've spoken many times before. You've seen that in normal maths as well. You've used that in polar coordinates as well. So guys, can you just take a pause and do this integration yourself, then we'll come back to it. So using this cos 2 theta formula, I get sine square theta is half minus half cos 2 theta. I advise you that you can memorize this anyway, people, if you can. Okay, so this is integral of half, then integral of half cos 2 theta. Okay, and that gives you 1/8, obviously is outside. It is theta over 2, and minus cos 2 theta's integration will be sine, so stays as minus, is 1/4 sine 2 theta. Why is that 1/4, people? Reverse chain rule. In formula is sine 2 theta, then divide by the differentiation of this. Right, so now we're ready to put our limits in, but very important, people. Substitution, my limits are given to me in terms of x. I have to make sure I change my limits in terms of theta. So I do it from here, people. Okay, do that when x is equal to 0, find what theta is. When x is equal to 1/4, find what theta is. Let's see, guys, we come back to it now. Solving simple trig equations, guys, that gives me when x equals 0, theta equals 0, when x equals 1/4, theta equals to pi over 6. Guys, that's what we put, theta equals 0 and theta equals pi over 6. Substitute these two values and evaluate the integral. Guys, this is what I get when I substitute these in. So I get 1/8 there. This is pi over 12. And sine pi over 3 is √3/2. This minus √3/8. Okay, so we start evaluating, but since it's a show that question, I have to go back to this bit. Okay, so that gives me pi over 96, take away √3/64. So lowest common denominator, lowest common multiple of that will be 192. That gives me 2 pi minus 3√3/192, which is exactly what we want here. Guys, that is your question.